field research opportunity working with a university on the East Coast somewhere where they're trying to measure the spread of invasive algae, so they need students to establish and monitor hanging plates in coastal areas to see if that algae is moving in. Remember I told you the little PVC things that you would hang down at the harbor and monitor them once a week and take a photo and upload it or something?
Yep.
Those people got their funding. They'd like to use Santa Barbara High School. They want to start testing, I think, in April. So you've got about 3 weeks left to work the details out with ibargeprogram@gmail.com if you're interested. I don't really know how many students they need. I kind of got the vibe from them that, like, yeah, if you got a student, and I told them, like, yeah, I've got like 40 that seemed interested, and they were like, do you have 40 harbors? So I don't know, like, how many students they'll need, but you can send them an email and try it out. If I was you, I would do it right away. So, hey, if you still need more students, I'm interested, just throw that out there. Next. You probably heard about the other one because you're a MAD class. You may have gotten an email, I think, from Pablo. Y'all call him Pablo? Yeah. About this thing, there's like a political organization called the Gaviota Coast Conservancy. They're trying to prevent development on the Gaviota Coast. And they're looking for students to do artwork for their political efforts. Funny thing is, politics is personal. And I sort of feel like everybody wants high schools to be involved in their political cause. Just like everybody wants high school students to be involved in all sorts of stuff. And frankly, if I were you, that's personal. Like, who you choose to make out with or whatever. Like, I don't want to whore you out to other people's politics. Like, if you insist on being politically involved at your age, then I would say be kind of judicious about that. The tricky part about this effort is, the funny thing is, I sort of don't know where I fit in. Like, I don't like development of the Gaviota Coast, but what they're trying to develop is probably some of the more righteous things you can build. They want to make a recycling processing center and a bio-waste digestion facility, which is like kind of cool. And that would expand the existing landfill to be more like sustainable and forward-thinking and cutting edge. And to me, that's like, yeah, let's do that. Except it's on the Gaviota Coast where I'm like, no, I don't really want to develop right there. And so it's one of those honest trade-offs. Like, you can have an opinion, that's great. I don't actually, my mind's not made up. But if you want to talk to this dude, he's looking for students to do artwork. It could be like a group art project, and it could be like a little portfolio builder, and I don't know if there's like a contest or a stipend or an internship or what. But it's up to you to reach out to him if you're interested. I just said I would tell you, so I told you, and now I'm done talking about it. Any questions about the Ecotopia, the Green Club this Saturday, the Student Environmentalist Award, the iBarge, or the Gaviota Coast Conservancy?
Is there any extra books for the
There's one. Were you absent yesterday?
No, I'm just interested. You said it was
I'm going to wait, see. I'm going to probably do a drawing for the students that were absent yesterday.
I have one. I don't want it anymore, though.
See, there you go.
I'll bring it tomorrow.
BBK is kind of over it. So. Any other questions? Yeah.
Is the curve on the test ABU?
So about your grades. Your grades include everything in Unit 7 except your article submissions, and your weekend extra credit for Unit 7. Got all the homework, all the movies, all the exam. The exam, as I predicted, was kind of brutal. It is curved. This is the lowest curve of the year. And despite the lowest curves, this is the most really bad performances of the year. We knew this would happen. It's probably better that it's at the very start of the semester, so you've got a lot of time to heal. Yeah.
Is that because Unit 7 was when we went to Mexico?
Well, there's a whole bunch of reasons. Like, you know, going to Mexico, by the way, like statistically, going to Mexico does not seem to have hurt the math classes. The math classes did roughly as bad or better than my average classes. Maybe going to Mexico was helpful. I don't think, it doesn't appear to be an additional problem.
Yeah, I didn't go to Mexico and I still got a bad grade in 7.
See? And you should have gone to Mexico, bro. It's good for you. Yeah.
Oh, the city council meeting, was that Unit
That's Unit 8, because it's about water. Unit 7 was about energy, and I want to remind everybody, we knew that would be difficult because it's 5 units, so 5 weeks, spanning 2 semesters, with finals in the middle.
Yeah, that one was a bit
You got a gross one?
There was like a worm in it or something, that was terrible.
Daisy ate a worm, everybody. Daisy ate a worm.
I didn't eat it.
She also has food in her eyes. Okay. We knew it would be difficult because it spans 2 semesters. There was finals in the middle. Obviously, there was the MAD trip in the middle. Obviously, energy is nitty-gritty with a lot of details. This was the first exam that you had to like actually generate chemistry. Note, it will not be the last. And so I can understand a lot of reasons why students would have done badly. Funny thing is, like, the high scores were about as high as the usual high scores. There are some kids who can still pull it off even in this case. But all things considered, this was a brutal test for all my periods. There are some kind of good news. For one thing, there's a lot of extra credit available in the second semester because the entire review process for the AP test is all extra credit. So in about 2.5 weeks, before the AP test, you can earn about 25 plus extra credit points. I really try to pay up big on getting students to review for the AP test. Then second of all, half your grade in this semester is the year-end project. So for some of you, it's like, crap, I've been struggling to get an A, and now I do badly on this project, and it can sink you. But you're graded in large part on how hard you work on that project. We'll talk about that grading later. So for a lot of you, like, oh man, I've been trying really hard and I got this horrible test starting the second semester, don't sweat it. Because there's like, statistically, most student grades go up in the second semester.
Is that because some people drop out?
No, I mean like, over the course of the first semester, if you have like the average grade on the report cards for all my classes, it kind of goes like that. Statistically, if you take the average grade for all my classes in the second semester, it kind of goes like that. Like the end of the year usually bumps kids up because of all the review for the AP test, and then the year-end project usually heals more students. Yeah?
So are the movies not happening anymore?
I'm kind of feeling like no. There were only a couple left in the last couple of units. There would have been 2 in this one and 2 in the next one. And I have heard so many horror stories by now. Every time I'll have a conversation with a kid, they'll be like, why'd you stop it? And I'm like, oh, you know, because I got these like parents that were telling me that like kids were like walking out or showing up late or like copying their answers or not paying attention to the movie. And everybody's like, oh yeah, well I saw a lot of that. And like, apparently those things were like really common and that was happening all year. And so basically kids have peed in the well and nobody else wants to drink it now. I think that some kids really were doing great and got a lot out of it, and I'm proud of them and I'm sorry for them. but there was a lot of kids that were just blowing it off, and it's too hard to do this without like cheating. I kind of thought that we were controlling that. Apparently, we weren't. So I'm sort of frustrated.
What about the city council meetings?
What?
What about the city council meetings?
What about it?
Like, are we gonna keep doing those the rest of the day, or how?
Well, I don't know if there are any other city council meetings coming up that are relevant to our content. Like, I'm open to other things, but. All right. Remember that at this point, the grades are very misleading. If you blew it on like one thing, your grade is really low. Like, if you just had like one little mistake, like the last semester, if you forgot to turn in your packet, that's like a easy 30-second correction. But if you got to turn in your packet, you probably have an F. Like, it's super brutal because at the beginning of the year, you know, like the basketball game starts, Kobe comes out, misses his first free throw. Like, that doesn't mean he's going to suck all day. That just means he like has a 0 for 1 at the very beginning. A lot of you have like a 0 for 1 because you just had like one mistake at the beginning. I wouldn't worry about that too much. And you'll get to see your test on March 25th. Maybe it's just a typo, and you might have a bad score on that Unit 7 test because I just entered the wrong thing. So we can fix all of that if that's a mistake. Are there any questions about the Unit 7 grade? Anybody have a question about the Unit 7 grade? Next. About your solar house models, which are due in like 20 days, is that right? Yeah. Ooh-wee, 20 days. That's fun. I strongly recommend you write a couple of things down about your solar house models. You don't need to write this down, but you'll want to start early. Like, start today. And, James Mel, put your cell phone on top of the solar house, please. What? I don't care. You can use paper like we used to in the old days. Put your phone on top of the solar house model over by the truck. Thanks, buddy. All right. It's this new thing called paper and pencil. I'll fight you any day of the week, James Mel. I'm not afraid of you. Any day, bro. 3 p.m. flagpole. Yeah. All right. What's that? Or take apart? Is that where the kid's going to fight? No way, for real? Is that a thing? That's not a thing. You're just messing with me. Let's go to the bar, fellas. Who's that, James Mel? All right. Damn you, James Mel!
Sprinkler's gone.
Okay. You should start right away because statistically, nobody turns in their first draft. Like year after year after year after year, like talk to students who took the class last year. No matter how much I warn my students, like the first one is just to kind of like look at it and feel it out and start thinking about it. I would suggest you make like a preliminary cardboard shape only that nobody's going to turn in, where you just like draw in the windows and make sure you've got like the scale right and the dimensions right. Just to like have it sitting around so you can think like, yeah, we're going to need like that much and this piece, and like just try to make one that just represents the basic outside shape that you'll never turn in out of cardboard, just so you have something to look at and talk about. On that one, focus on the scale and the geometry. You're not going to turn it in. Get your dimensions right. 1,000 square feet of floor space equals 1 square foot of floor space. You can check your angles, you know, like just print out an angle on a sheet of paper and hold it up to the side and trace it, and those are your roof lines or whatever. Look, every single year on the day the solar house model is due, I see more people crying, more parents bringing in homework, more students walking in with like pajamas and like runny mascara and like eye boogers. Like, I have seen kids come in with solar houses literally like crying because like the glue was wet. When they hit a speed bump, it'll like fall over. I have seen like wet clay like collapse. Like literally, oh my god, you guys! And then like all crying because like the thing like fell over. I had a math class that built a house that looked like an ice cream cone with like a... She is, thank you. Daisy Mahoney, you got lust detection?
My dad refuses to call in when I'm not here. He's like, I called in yesterday, I don't need to call in again. I'm like,
Dad, figure it out, bro.
So annoying.
He doesn't know. Okay. I saw a math class that tried to make a round house with a skylight that looked like an ice cream cone, and it was made of clay. And literally 3 girls cat fight like right here because like one of them was like, "You said it was dry," and the other was like, "You said you got the fast drying," and they were like seriously getting at each other, like super nice, polite. Like I always thought they were cool girls. Like straight up like getting in faces, and I thought they were gonna like literally like brass knuckle it. Like literally, mark my words. We could take odds on how many, but at least one person will bring a house made of tears on the 24th. I know for a fact it'll be at least one group.
Per class?
It'll just be like a heap of like tears and humiliation. And they'll walk in like, "My dad made me come, but this sucked and I know it failed." Like, every year. And like, the groups that walk in like, "Yeah, I finished early." Like, they're the ones that start early. Like, trust me, make a cardboard one for now, figure out the details later. Plan on making 3 or 4 houses and turning in the last one. Really. Next. We're like 15 minutes behind the other periods. Next. Modeling, in the scientific sense, is not making it look like you're drawing. It's making it act like you're drawing. Whatever changes you make to the plans between now and the model, you're bringing me a model of those plans. Like, I will grade you by how accurately your model shows the plans. So,
do you have any like containers you want to put the potassium iodide in?
either borrow a jar or get one of the glass beakers. And Daisy, how much do we need?
I don't know.
Ballpark.
Well,
200 grams?
maybe. Is this our going to make a paste to like paint onto the strip? And I don't know how much.
How much water do you think we're talking? It's 5 grams of cornstarch and 1 gram of KI for
100 milliliters of distilled water.
100 mil of distilled water.
Yeah.
So that's probably enough paste for 100 mils, not a lot. So a liter would probably make a class, so we need 10, 50, I think with 200 grams we'll have plenty.
Okay.
10, 50, 200 grams. Yeah. Tears of victory.
Hey, that's my guy.
I pulled it out of all the red I tried to build it. Hey.
Back to me. Sorry, that was not your fault, but now we're further behind. Even further behind. Getting even further behind. Put the phone back, James Val.
Okay, yeah.
You're going to become my pet project. I will break your spirit like straw in the hands of a giant. I don't care. I want to ruin your life, James.
Thank you. 3 times.
Okay. You're modeling the function. So, trees, they don't have to look like trees. Get yourself a cardboard box.
Whoa.
Make a cutout. Also, look, it's a bikini. But look. Check it out. In summer, you've got trees with leaves. In winter,
Whoa.
light goes through. That's what I mean by modeling.
I don't get it. You cut the cheese out.
So in summer they're there and in not.
Right.
Going past.
Okay. Or not. I don't care.
Oh.
Wait, how do you put that on?
You feel with the table.
1 second is like.
Show us again, but slower.
This is really gnarly, right? I was like, whoa, guys, I need some notes on that. What do I write? Okay, next. For insulation, like, make sure that you pick something that actually functions as insulation. Insulation's not very tricky. You can buy this, like, foam board, like those posters that a lot of you made. Those, like, rigid, kind of foamy poster boards. That, like, one sheet of that would probably do 2 or 3 or 5 houses. It's really important that you seal the houses. Trust me on that. Like this little house, it's got this hole right here that I can almost stick my index finger in. If you compare that to the scale of a house, that would be like opening this giant window. You know, like, if you have that giant window open, you're not going to build a lot of heat because it's going to leave. In the scale of your homes, you'll want them to be airtight.
That house made out of gravel?
Yeah. Stucco, you mean?
Oh, yes.
You'll have to check your geometry. The funny thing is, a lot of my kids like blew off that like 54, 30 degree, whatever, 36 degree thing. But my winter and summer sunlights, they are set precisely. Like the front edge of your house has to be at the line of tape, and we will level the light to your house so that the light comes in at exactly 5436. Like that geometry, there's a reason that I made you give me the length and the angle, because you have to make it that way so the light will do what you said it would. You have to actually model that. And we'll check that. When we plug it in, I'll be like, yeah, that hits the light in the winter, that light hits, okay, great. Like, good luck, you gotta actually do that part. Next, if you'll notice my houses, the base is small. The base is just bigger than the house. If your house is and if your base is too big, I will not store it for you. I have very limited space. So if you could please look over there. You see how big that one is with the 2 steel trees in the front? That's the only one that I've ever kept that was big because they welded their own trees. But otherwise, like, there's no way I'm going to let you store big old bases here. Next, the one that everybody's worried about, the Adobe. Here's some things you cannot do. Might want to write this down. You cannot make adobe in this scale, and you cannot use clay in this scale. I'm sorry, but both will dry out too much, they'll crack, they fall apart, the moisture dynamics in the greenhouse won't work, and usually, like, the straw in adobe, you cannot replicate at 1/33rd scale. You'll want a wall that is, you know, like 5 to 10% miniature air pockets. So to replicate the function of adobe, the best I have found is screen sifted concrete. You buy like a cheap $3 bag of the most generic concrete you can find, not the fancy like overnight post setting kind, but like the really, really cheapest concrete you can get, bulk. You can probably split that much concrete with 2 or 3 other groups, so everybody fits in like a buck or two. And then you screen it through like a colander so that the gravel is removed. You just want the fine filtered powder. Then you can mold the walls with little cutouts for the windows and glue them together after they dry. It might help if you can get your hands on it to use what's called a concrete saw or a tile saw to cut them into pieces. You can, if you want to try it out, use terracotta tiles if you can find someone to cut them for you, but that's not easy. Yeah?
On that model, do they have something below the concrete? Like,
There's a foundation.
like no, on the walls, or is it just?
No, that's just 1, 2, 3, 4 sheets of concrete that they molded in place. So they made the mold, like, I don't know, a cardboard box or something that they poured it into. Maybe like spray like ham or something into olive oil or something so it won't stick. Yeah. Yes.
Okay. If we have like tile floors inside, do you want us to make it so the roof can come off and you can see inside? Or
No, your door will
your
open.
door? Okay.
Yeah. Yeah.
Brandon, did you say that you can use terracotta tiles for the walls?
You can, yeah. Terracotta works really well, but you'll need to cut it.
Yeah.
And cutting tiles is really tricky.
What do you Oh, my dad has a tile saw every time so we can
Everybody wants to go hang out at Hope's house all of a sudden.
Wait,
If you can get your hands on thick terracotta tiles, like 3/4 inch, and if you know how to use that saw, which is not trivial, like if you're really, really careful and delicate, then you can use like a tile drill to like cut out the windows. That could work. I've done it. I just don't know how many high school kids will be able to pull it off.
So that would be in place, like for Adobe.
Yeah, that could replace. So terracotta, concrete, and there is a third option, which is more expensive to purchase and more difficult to make on your own. It's called papercrete. Anybody ever made paper? It's like a lightweight concrete with paper fibers. That's what these two houses are. This is papercrete covered in stucco, and this is just plain papercrete. Like you can grind it away with your fingers. It's paper fiber held together with concrete. Next, if you're going to have a house built into a hillside, don't use dirt. Don't use dirt. Because real dirt, scaled 133, is too much empty space. It's too much air. So if you want to have a hillside, make a cardboard cutout of the slope, but then fill it in with sand, like from East Beach, because you want it to be mostly rock, very little air. Remember, it's 1/33rd scale. Everybody got that? So you can just like grab a bucket of sand from East Beach, pour it between the house and the hillside. You understand what I'm saying? If it's not staying put, you can paint it with like Elmer's glue sand. Like a layer on top that'll harden as like a stiff layer of sand to hold it all together. Are we cool with that? Yeah.
What's your favorite solar house design in the class?
I don't even remember that.
I don't know, I mean like,
Oh, in the room?
yeah, in the room.
like as far as model quality goes, this was a respectable carpentry project, but it sucked as a model. This was the most crazy idea that I think with like a little more effort on the house part really could have worked. This was a really hell of an effort, and the architecture intern that this kid hired did a wonderful job. This was actually like pretty ambitious and good. Oh, by the way, instead of concrete, you can try something called hardy backer. If your dad knows how to use a tile saw, he probably knows what hardy backer is. It's this concrete stuff with a lot of air pockets that people use as a backing for tile projects. You could try hardy backer. Yeah, that's probably one of those would be my favorite. Yeah. Say what? 133. So 1,000 square feet is the design, and that has to fit into 1 square foot. So that's a 133 scale. Your model's 1 square foot of floor space. Any other questions?
Yeah.
So like doors, like do you want them just like to have a door or just be open for the gate?
Oh, your house will be built for 2 seasons. So you're going to build it as if it's winter, like seal all the windows and stuff, and then for summer, we will just peel off the windows for open window, and we'll pull off the door if the door is part of the ventilation system. And if you need to like open the sunroof, you can just cut a hole in your roof. Because you're modeling the function. Does that make sense to everybody? So you'll build it for the winter. After the winter, you'll punch holes in it for the summer. Yeah?
Are trees to not have leaves on them?
I don't care. If you want to use leaves, go ahead. But whether they are leaves or not trees. Oh, yeah, you mean this? Yeah, right. So you would have winter, summer.
Can we just take our trees off? So
Yes.
Oh, we can just move them.
Yes, you can just move them.
Okay.
Yes.
No, that
And that one, they just pull those off, yeah.
spectrum or whatever. All other designs will be an automatic fail.
All right, yeah.
They're not
When you test it, how does that do?
You test it.
Oh, we do. And then we get a grade on that, or?
On your lab report of how it discusses the performance relative to the design. I'll explain when we get there. You just build a good model.
But like, what if like for some reason they don't?
Then your lab report gets a lot longer.
Okay, but
Yes.
How long do you get an F for it not working?
I don't know.
just like this.
You just have to explain why it doesn't work.
Are there any other questions for me? Because I'd like to move on. All right. There's like 7 active cell phone usages right now. Please put those away. And it's not James Mel. Don't make me get all James Mel on you, kids. Take out your 9.2. We've got a few study goals.
9.2.
Yeah, so she was like,
It's hundreds of dollars.
Oh,
so
great. No, I don't think we did. Will you give me a more accurate estimate of how much we actually need? Do you think?
I am. So, I don't know, because you just have to make the paste and then paint it onto the strips. And I don't know how far.
100 milliliters will reach.
Yeah. The card says you got it, like, you got to make a lot of paper. And,
That's great.
yeah, I don't know.
she'll send somebody in and carry it.
Fish food. Thank you.
And
That's it. It's
we
12
have
o'clock.
everything else we need except,
Great. I'll have someone buy that today. All right, children, excuse me. There's a few study goals that are really critical that I'd like to get through quickly. We don't have a lot of time because we've had a lot of little distractions today. Like how Baylor won't stop talking and she's messing with Hope Dalton's schoolwork. She's a bad person. Like that. That sort of distraction. So let's do this really quickly for number 11. I hope everybody knows the most common gases. If you fill your lungs, that's all nitrogen.
And oxygen. And a very, very small amount of carbon.
And for number 12, you've got this drawing. This drawing has a lot of really fundamental information. I'm sure you've noticed by now that the last 8 units, on the very first day, I go, look, these are the basics that we're going to talk about. And then for the whole unit, I keep dropping all those terms and stuff. By now, you all understand that those first couple study goals are like the setup for the unit. So this is it. There are 6 things that you should draw from this diagram. Number 1, the atmosphere has layers. Each of those is different. Like a jawbreaker, like our atmosphere has distinct layers. If you could please look up, we live in the troposphere, that's the bottom. Then after the gap called the tropopause is the stratosphere. Then there's a stratopause to the mesosphere and a mesopause to the thermosphere. And technically, there's a last layer called the ionosphere, which is pretty much getting into outer space.
Ionosphere being like where ions travel? Like magnetic fields or something?
Sort of. So fact number 1 is the atmosphere has layers and each of those layers is distinct. If the Earth were the size of this butt-looking pumpkin, if the Earth were this size, the atmosphere would be less than a layer of saran wrap. As a scale issue, that might seem like not very much atmosphere, but you might want to think of it as a really big Earth. But in that diameter, 1 layer of saran wrap, it's a fraction of a millimeter, is the relative thickness of our atmosphere. Within that little tiny saran wrap, there are distinct layers, each of which is different. And a lot of my students struggle with this. But each of those layers has different ingredients, different temperatures, and different types of chemistry. Like, our atmosphere is not all one thing. You cannot survive outside our layer. In any of the other layers, you would just die. In a couple of them, you would melt and become messy rain. Like, each layer of the atmosphere is distinct. And so their chemistry is different, their issues are different. So when we talk greenhouse effect, that's over here. When we talk ozone layer, that's a separate set of chemistry. You can't discuss this chemistry down there because down there is different. Fact number 2. What is the source of our atmosphere's heat? No.
Kind of like sun.
Look at me, look at me, look at me. If the sun was our heat source, getting closer would be getting hotter. If I get on a rocket ship, am I going to be much hotter when I'm right there? No, that's outer space, negative 231 degrees Kelvin. Because you know how close you'd have to get to the sun? The sun's really, really hot. And watch. Colder, colder, really cold, really cold, really cold, really cold, really, 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 really cold, 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 cold. All of a sudden, hot, and then vaporized. But to get heat from the sun, you've got to be like right there.
Are you serial?
I'm dead serial.
Dang.
You see, here's the part that I think a lot of people like. You all know this. And yet, the logic doesn't sink in. We all make this mistake. The heat source is not the sun. It is the earth. Not like the core and the magma and stuff. I mean, like a black sweatshirt when you're chilling in the sun, light is absorbed and heat is radiated by the earth. Just like that. Yes?
But it's still livable then?
Oh yes, I didn't ask what is the energy source. That would be too easy. And this is where we stumble. Because heat is a very peculiar type of energy. And heat doesn't travel very far. If you were on fire, that's pretty hot, I wouldn't know.
Well.
I mean, I wouldn't care. I mean, I wouldn't. I wouldn't feel it. I wouldn't feel it. Because heat doesn't travel very far. Look, this is not a trivial distinction. When you get right down to it, a lot of people don't understand very fundamental basics, and it confuses conversation for days to come. Let's be absolutely clear. The light source is the sun. That sunlight hits the earth. The earth gives off the heat. So, as you move up in elevation, temperature goes down. The heat source is the surface of the earth. And yes, hot air rises, but as it rises, it dissipates and cools off. So like, if the skillet's on top of the stove, yeah, hot air rises, but the air is colder. Everybody got that? Hotter, hotter, hotter as you get closer to the skillet, right? Like the funny thing is, everybody understands what I've said, and watch how often people will make that mistake. In the next 4 weeks, I'll be like, no, but the heat source is the earth. And it's like, oh, right. Yeah.
Wait, so why is it that as you go up in elevation, the temperature goes down?
Because where's the heat coming from? And you're further from it when you go up in elevation.
Wait, what's the elevation? Or what's in the air?
Either. When you're up on the mountain, you're surrounded by a lot of air, and so the heat is just less heat around you. Yes, if your feet are touching something, then yes, that spot will be dissipating the same amount of heat. Yeah.
How can a planet
All of
be
it being
gas?
But that layer at that elevation overall, that's mostly above the heat. I understand your question. So. Number 3. The third of the 6 is the fact that gravity works on gases too. So most of the atmosphere is being dragged down by gravity near us. There's very little atmosphere as you go upward. And because the volume of a sphere is like a cube root function, the concentration of gases is like a J-curve.
Exponential.
Yeah, exponential curve. So most of the gases are right down here. Please look up. 90% are right there. And 99% are right there. And all of that has almost nothing. Well, it's nothing. It's very little. There's not much there. Because, like the lazy gases get held by gravity. The only ones that can escape gravity are extremely volatile. So chemistry above that 99% mark, chemistry up there is totally different. A, because the only ingredients are like super reactive. And B, because of different energy content we'll talk about later.
That's ozone?
No. Yeah.
That guy, I think Felix that did the highest free fall.
Yes.
How high up was he?
If I'm not mistaken, he was off this chart. That's why he jumped in an astronaut suit. If he had jumped like this, he wouldn't have hit the ground.
He would have exploded.
I mean, I'm not really an expert on the rate of but he would not have been alive when the remains hit the ground, whatever remains we're talking about.
Yeah, he would have kind of like exploded, right?
I don't know. You know?
Because like the pressure inside his
Oh!
body's like.
If he didn't have an air can, he would have passed out, come back to life, passed out, and then hit the ground dead. Yeah. Okay.
You were asking about the hang glider. Oh, well, yeah. I'm not sure what his name was, but
I am now.
his daughter. Yeah, he was like a veterinarian, and his daughter, Sierra, went to my grade school, and he had a couple years before broken his back hang gliding, and then just another.
And their house burned down.
their house
I thanks for filling me in on that. You're right that I was curious. By now, I have verified that it wasn't one of my homies, and separately, I've heard a lot of horror stories from that community because some of the big time flying people in town are old buddies of mine, and so I've kind of had it up to here with all that grief, man. I'm not really good with bad news. I can't really
You're an environmental scientist.
Yeah. That may be why. I kind of I already wallow in bad news, so personal tragedy I just don't deal with very well. I don't know. Thanks, but no more. I'm topped off. Number 4. Look at that blue shape right there. There's this thing called ozone, and you must write down that ozone equals sunblock. And that's not real science. It's not really sunblock.
It's just filters, right?
But in a very fundamental sense, it's a lot like sunblock because it bounces back ultraviolet.
Why?
So let me say this, and then you can figure out what you're going to write. Let me say this, and then you can figure out what you want to write. Ozone is one of those more active gases. So ozone escapes that 90%. You see what I'm saying? Ozone is above most of the gases because it's more active than most of the gases. So gravity has trouble holding on to it. It's like a hyperactive child. So ozone goes up to about 20,000, 30,000.
20 to 30.
Yeah, let's say it's pretty close to 30,000 meter mark. That's like 90,000 feet. That's like way above airplanes and stuff. Ozone is up there. And now comes another little detail that's tied to 4. So I don't know if you want to make this 4 or if you want to make this 5, but listen very carefully because this confuses my students. Ozone blocks much of ultraviolet radiation. So down here, where we live, there is no ultraviolet C and very little ultraviolet B, because all of that got blocked by the ozone layer. Number 4 is ozone's over there. Number 5 is ultraviolet is above, very little ultraviolet down here below. When you see glasses that block ultraviolet C, that's a scam. Unless you plan to be an astronaut, you don't need those.
What about in the ozone hole area?
Even there, ozone depletion allows exactly 0 ultraviolet C to come through, but separately ultraviolet B goes from 1% of open space to 3%. It's triple the amount we usually get, but it's still very little. Yeah?
I'm still confused where the ozone starts.
Okay, it starts at ground level because some amounts can be held onto by gravity, but the concentration peaks at about 10, 27, 28,000. Almost all of the ozone is above our clouds and thus above our weather. Everything that you know of the atmosphere, anything you can talk about the atmosphere, occurs below those clouds in the troposphere. That's the human part. That's the living, biotic part. Ozone is above that, and ultraviolet is above that. That's why I said that if you jump from outer space, you're going to turn to mush before you hit the ground. Because up here, you've got straight up ultraviolet. All of UVA, all of UVB, all of UVC, your bonds fall apart. You go vaporize.
Ooh, that's cool.